And yeah, good afternoon all the participants. So let me just see whether I'm able to share the screen or not. Then we will start. Okay. So what I will do is I will give you a brief idea about today's agenda, what are we going to discuss and how our approach is going to be. So what I will do is I will try to make whatever 2 hours, 2.5 hours, whatever we got, we will try to make it as practical as possible, as hands-on things as possible. I will try to cover, and I will try to at the end I will try to talk about end-to-end machine learning or data science project also. Okay. Just a minute, let me see whether I am able to share the screen or not, and let me know if it is visible to you. Okay. So, okay, I hope everyone is able to see my screen. Just participants, please let me know either yes or no. I hope my screen is visible.
Yes, sir. Your screen is visible.
Yeah, thank you, sir. Uh, yeah, that's okay. So, as I told you, I will start with the agenda. What are the points which we are going to discuss, so that everyone will get an idea what you can take from this particular session. As I told you, I will try to make it as practical as possible. But let me know what you people are aware about, because let me first of all show you. As I had a look on these previous sessions, the topics of these previous sessions in this 2 weeks of FDP. So I hope you people are already aware about these things. The topics like fundamentals of programming and specifically Python for data science is done, right? Then I think you already have a basic idea about deep learning, right? This thing is covered. Foundation of deep learning, and one more thing. What I am going to do is I want you to make some sense out of all the packages which are available. There are some basic packages which I am going to make use of, even in the project also, right? So you are already aware about the concept at least, and this one, introduction to a foundation of deep learning and introduction to machine learning, this is already covered, right? So I hope that you people are aware about what are the different approaches of machine learning, like supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement machine learning. These are the approaches for machine learning which can be solved to which can be used to solve the problems of classification or prediction or regression, we can say, right? And here you have already done with hands-on on machine learning. Maybe with R, but the concept is going to remain same. So, what I will be hoping that you are aware about some of the basic things already, so that let me write down all the points which I am going to make. So what I am going to need is my agenda is going to be like this. I will start with maybe I think I don't have to spend much time on these topics. So first of all, introduction to the terms, right? So I hope you are aware about what is machine learning, what is data science, right? What is artificial intelligence, and what is deep learning, and what is the difference between them, right? So with this, we will continue with this assumption. If anyone is having any difficulty in between, please you can ask, because I also want this particular session as interactive as possible, right? Another thing is like what is data, what is database, what is RDBMS, all those basic concepts you are already aware about. Now, so I will just try to touch upon all these points. Maybe it will take 10-15 minutes only, not more than that. Right. And then, as I told you that types of machine learning approaches, right? So this is what I also need from you people. You should have a idea about all these things. So what is supervised learning? What is unsupervised learning? What is semi-supervised learning? And what is reinforcement learning? Right. So again, in 5 minutes, I will tell you in a brief about this. After that, what I will do is, as I told you that we will try to do some hands-on these topics. So I will be talking about an application or a project. We are going to develop a project with the help of one of the basic algorithms which is available in machine learning to start with, and that is nothing but linear regression, right? So I will show you the application or a project, you can say, which is actually created or which is actually built with the help of a linear regression algorithm. So here what we will see here from the start, we will see how to fetch the data, how to clean the data, how to do the exploratory data analysis on that data, and finally how to come up with a model. So what we will do once that model is trained. So how to train the model even once that model is trained. I will also show you how to deploy that particular model onto cloud. Right? So we will be doing cloud deployment. I will be showing step by step how to do a cloud deployment, because without deployment we cannot say your work is done. Unless and until we don't deploy a project onto the cloud, right? So the customer or the what you can say the consumers, they are not able to make use of that, right? So the project which we are going to develop here in third step, I am going to show you how to deploy that particular project onto cloud. So whenever I talk about cloud, uh, there are different options here. So Amazon Web Services, you might have heard about. There is something called as Microsoft's Azure Cloud. There is something called as Pivotal Cloud, right? And there is one more cloud which is provided by Google, that is Google Cloud Platform. And one more is there, that is Heroku. So like this, there are number of cloud platforms which are available. But what I will be doing is, for all these things, AWS, Azure, Pivotal, or GCP, for all these things you require credit card or debit card details. But for this Heroku cloud, you are not going to require that. So it will save our time. So I'll be showing the deployment of this project onto Heroku cloud. I will show it step by step how to do that, and I'll be sharing that particular project with you, so that you can also go and you can also make use of my project. Right? Once that is done, and if we have time at the end, I'll be showing you an end-to-end project of machine learning or data science, where we are going to make use of some real-time data. Okay. And generally what happens in real time projects, again, when we people also try to develop some models, what we do is we do not depend only on one algorithm. What we do is we try to make use of 6 to 7 algorithms at a time. So that is the thing, but end to end project, that's what I want to show it to you. So it all depends on time. If we have a time, definitely I will go through the code also. I will explain you the logic behind that and the flow of that particular project, right? So these are the things at least I will try to cover in this today's session. I hope everyone is clear about that. As I said, in between, if anyone is having any doubt, you can please you can actually ask your question, no problem, right? And let's try to start with this. So as I have already seen in the schedule which I got, right, for this FDP in the previous sessions, you have already been introduced to machine learning concept. Here, I will just try to differentiate these four terms, right? And in a brief, I will try to tell you what is the difference between them. So you might have come across this kind of a diagram. If I ask you what is artificial intelligence, so artificial intelligence is the bigger umbrella. You might have seen or you might have come across this kind of a diagram many times. So artificial intelligence, if I want to define, it is the thing, but what it is just to enable computers to think. That's what artificial intelligence is, right? To enable computers to think like humans. That's what AI is. In a brief, if I want to tell you, to enable computers to think like humans. That's what AI is, right? And as I told you, AI is the bigger umbrella. So whatever it may be, whether it's machine learning or deep learning, all those things are going to come under AI, right? So to enable computers to think like humans, that's what artificial intelligence is in simple words. Now talking about this particular term, machine learning. What is machine learning? So machine learning is going to come here. Again, see, I will tell you where people will be having some differences in the definitions or in the concepts of all this. I will also discuss that particular thing. That is the only point why I'm trying to discuss this basic thing first, and then only I will go and I will try to discuss about the project. So where machine learning is going to come? Machine learning is going to come somewhere here. What is machine learning actually? Machine learning is a bunch of statistical tools. It's a bunch of statistical tools which can be used to learn from data. So bunch of statistical tools is nothing but machine learning. And those tools are used for what? Those tools are used to learn from data, right? So, in simple words, that's what the definition of machine learning is. And what are those statistical tools? We will see that. We will talk about that. So, that is AI, there is machine learning, and then there comes an important term, and that is nothing but deep learning. We will talk about deep learning in tomorrow's session, again with some hands-on example or some project. So what is this deep learning concept? So it is a much more recent term, maybe since 2006 or 7 it is there, right? And this is all about using something called as multi-layered neural network. I have seen that In the morning, I think you people are already introduced to the neural network concept. So deep learning is something about making use of multi-layered neural network, right? And you might be knowing that right now there is something which is called as Google's artificial intelligence system, right? So it's a very famous term people refer to as Google's AI systems. They are mostly referring to Google's deep learning system. That's how Google's this particular deep learning concept is very very important. So you can say that some of the most important advances in artificial intelligence in the last 10 to 12 years, which are happening, they are happening in this small area, and that is nothing but deep learning. So I will not talk much about deep learning here because our topic is to discuss about the case study of machine learning. So I will try to move to the next topic. Okay, but I hope you got an idea about deep learning in a short. So if that's a deep learning, now there is a question where this data science is going to come into picture. So if this is artificial intelligence, machine learning, and deep learning, where comes the data science? So here many people will say that data science also comes under AI, or AI and AI actually comes under data science. But I will prefer telling you like this, right? Data science is somewhere here. So if you talk about this particular Venn diagram, I will try to differentiate between these terms in this way. Because see, let me tell you first of all, what is data science? Data science, you can see from this particular Venn diagram, you can see that data science has some overlap with artificial intelligence technique, right? AI. It has some overlap with machine learning technique, not so much overlap with deep learning, right? But data science also has other areas, right? So here you can see this particular side I am talking about. It has some other areas also. So in a nutshell, data science is all about understanding or making sense of data. Right? In simple words, I can say data science is all about making sense of data. Okay? So and you might have come across this particular term, visualization or visualizing, right? So visualizing the data is a very important aspect of data science, right? And for all these areas, artificial intelligence, machine learning, deep learning, or data science, there are some fundamental tools which are required. As I told you that we will discuss about those fundamental tools. So what are those fundamental tools? The fundamental tools like probability, right? So probability is there, statistics is there, right? Then linear algebra is there, right? Then matrix algebra is there. These are the statistical tools which are required, or fundamental tools which are required. Or you might have heard about something called as numerical optimization, right? There are numerical optimization methods, right? And yes, obviously, last but not the least, computer programming, right? So it may be R, it may be Python. Even you can go and you can make use of C, C++, or you can make use of Java and some other languages which are there, right? But the concept is going to remain same. So these are the fundamental tools which are required for AI, ML, DL, or data science, whatever it may be, right? So again, it's not like that one should be very much expert in all these areas, but yes, one should have an idea about all these things because they are very very useful. We will see in our project itself how you can make use of all these things, because we are trying to make use of we will try to make use of some mathematical equations for linear regression. See, I will be starting with linear regression because I want to show you a case study, and that case study or project is actually that particular model is actually developed with the help of linear regression, right? Because whatever we will see in linear regression, same kind of steps we can actually go and apply in case of other algorithms also, right? So these are some of the things, right? And other than that, what you need is approaches of machine learning, right? So or different approaches or types of machine learning people call it. So supervised machine learning. What is supervised learning approach? Where you are aware about input as well as the output. That means you in advance you are aware about, okay, what kind of output it is going to be. For example, you need to create a model in which you are going to predict the salary of an employee based on his experience, right? So in this case, what happens? You know what kind of output it is going to be. So output is going to be a continuous value. It is going to be a salary. So that kind of a problem can be solved with the help of supervised machine learning approach, right? So where you are aware about the input as well as the output in advance. So in case with the help of supervised learning, you can solve the problems like regression, okay, or I can call it as prediction, and you can also solve the problems of classification with the help of supervised learning approach. What is unsupervised learning approach? Unsupervised learning approach is something where you are not aware about the input as well as the output. For example, the types of problems which you can solve with the help of unsupervised learning are clustering. Clustering simply means grouping. So, for example, you have this data set, right? In this data set, you have a lot of data, but in how many groups this particular data set can be divided, we are not aware about that in advance, right? So that's a clustering where you can make use of unsupervised learning approach. So k-means algorithm or db-scan algorithm are the examples which can be used for clustering, right? Semi-supervised learning is actually what semi-supervised learning is nothing but supervised learning plus unsupervised learning, and that's what we are going to make use of in our end-to-end project, and that's what we people also make use of in real-time projects. I will show you how, right? So semi-supervised learning is nothing different actually. That's why you will see many people not talking about semi-supervised learning. They will talk about supervised learning, unsupervised learning, and reinforcement learning, right? So in our end-to-end project, we will be talking about semi-supervised learning. And reinforcement learning is what? Reinforcement learning is all about robotics. The best example is driverless cars, right? Reinforcement learning is a feedback-based learning or reward-based learning. For example, if you have created an application, or if you have a product, for example, a robot, right? Now, if that robot is expected to move one step forward, but if it is moving one step to the right side, that means that is not actually the correct action it has performed. So in that case, what you can do is you can go and you can give negative feedback to it, right? So what will happen? Next time it is going to remember that, and it is not going to repeat that kind of a mistake, right? So that is called as reward-based learning. But here we'll be talking about maybe supervised learning and unsupervised learning. So that is in a short introduction to all those things. Maybe you might have come across all those, you might have studied all those things in detail in previous sessions. That's why in a very short time I have given you introduction to all these things. I hope everyone is clear about this. If anyone is having any doubt, you can ask. Right now, what I will do, if you don't have any doubt, I will start with problem statement, right? I will try to discuss a problem statement which we will try to solve with the help of linear regression. And then I will implement one project with the help of linear regression, and then we will deploy. This is what we will try to do first. Right? Let me clear all these things, and let me show you a simple example of linear regression just to understand the concept. For example, you have some data or let me talk about this one first, linear regression. Okay, so linear regression makes use of equation of a straight line. That is nothing but y is equal to plus c, right? Where m is the slope and c is the y-intercept. So, for example, if there is a data set where we have the values, we have the variables like x and y. For example, x is the input variable and y is the output variable, right? So, what happens? Suppose if the value of x is 4, value of y is 3. Value of x is suppose 2, value of y is 4, and so on. It is 3, it is 2, right? It is 5, value of x is 5, value of y is also 5 suppose. And value of x is 1, value of y is 3, and value of x is 3, and value of y is 1. Now, we need to create such a model which is going to help us to predict the value of y, given the value of x. This is what we need to do. So what happens? What we can do here is we can make use of equation of a straight line, right? So how? Let's try to see. So as I have written the equation of straight line as y is equal to mx plus c, you can write it down like this: y is equal to b0 plus b1x, or we can write it down as y is equal to beta0 plus beta1x, where beta1 is the slope and beta0 is the y-intercept. Now, as we want to calculate the value of this b0 or beta0 and b1, so the equation for that one is to calculate the value of b1. Equation is something like this: b1 is equal to summation of x minus x bar into y minus y bar divided by x minus x bar whole square. So this summation is for here also square of this. So b1 is like this. That means if I want to get a straight line, right? If I want to get a straight line, I am going to need the values of beta 0 and beta 1 or b0 and b1 for example, right? So I need to make use of this equation. Now to calculate b1, what we need? We need x and x bar, y and y bar. Let me tell you what is this x bar and y bar. X bar and y bar are nothing but the average of x and y. So if you try to add all these things, 4 plus 2, 6, 6 plus 3, 9, 9 plus 5, 14, 16, what it is, 8, then 11, 13, and then 17. Is it correct? Okay. So calculation wise also it should be easy. Let me check it. Okay. So 4, 2 is 6, then 3 is 9, plus 5 is 14, and then 15, yeah, 18. So x bar is going to be what? 18 divided by 1, 2, 3, 4, 5, 6. 18 divided by 6. That means average is going to be 3. So that's what x bar is. And similarly, y also comes out to be 3. So x bar and y bar are nothing but the mean values or the average. As simple as that. Now what we need x minus x bar and y minus y bar. And that's what we are going to calculate. So x minus x bar, y minus y bar, we will calculate here. Okay, and then what else we need is x minus x bar whole square. So these are the things which are going to help us to calculate the value of b1, and once we get the value of b1, we can get the value of b0 also, right? So x minus x bar, in this case 4 minus 3, sorry, 4 minus this 3. Okay, 4 minus 3 is what? 1. 2 minus 3 is minus 1. 3 minus 3 is 0. See, this 3 minus 3, 5 minus 3 is 2, 1 minus 3 is minus 2, and 3 minus 3 is 0. This is what x minus x bar is. And similarly y minus y bar, y bar value is also 3. So 3 minus this 3 minus 3 is 0, 4 minus 3 is 1, 2 minus 3 is minus 1, 5 minus 3 is 2, 0, and 1 minus 3 is minus 2, right? And if you go and if you try to take the square of this, x minus x bar whole square, so it will be 1, 1, 0, 4, 4, and 0. And finally what we need is x minus x bar into y minus y bar. So x minus x bar into y minus y bar. That is multiplication of these two values. So what it will be? 1 into 0 is 0. 1 into minus 1 is minus 1. This is 0. This is 2 into 2 is 4. This 2 into 0 is 0. And 0 into 2 is 0. This is what we got. So finally what I will do is I will put all those values in this equation. b1 is equal to summation of x minus x bar into y minus y bar. So what is the summation of this? What is the summation of this? So it will be 4 minus 3. 4 minus 1 is 3. 4 minus 1, it is going to be 3. So this is 3, right? Divided by summation of x minus x bar. That means this one. What is this? 4 plus 4, 8. 8 plus 2, 10. So value of b1 is going to be 0.3. Right? This is what we got. Now as we got the value of b1, now we will go and we will calculate the value of b0 also. So how to calculate the value of b0? So here we have an equation y is equal to b0 plus b1x. We got b1 value. Now to calculate the value of b0, what we will do is instead of this y and x, we will take average value. That is y bar is equal to b0 plus b1 x bar. So what is the value of y bar? 3. What is the value of b0? We need to calculate. What is the value of b1? 0.3. Just now we calculate. And what is the value of x bar? Again 3. So here b0 comes out to be 3 minus 0.9. That is going to be 2.1. So we got the value of b0 as well as b1. Right. Now from this one what we can do is we can go and we can try to come up with the equation with a straight line. So see, I will try to show you a graph here. So your graph is going to be like this. This is what we are going to implement. Okay, so I'm just trying to discuss this example so that we will be able to correlate this to the implementation, right, or to the code. So see, what's here? It is 0, suppose this is 1, this is 2, this is 3, this is 4, and this is 5. Similarly here 1, 2, 3, 4, and 5. What am I doing? I am just trying to plot x and y values for x and y axis, right? This is my x values and these are my y values from this particular table. So from this table, if you look, if the value of x is 4, what is the value of y? So if the value of x is 4, value of y is 3. That means somewhere here, right? If the value of x is 2, value of y is 4, somewhere here, right? If the value of x is 3, so 3 2, 3 2 somewhere here, 5 5 is somewhere here, x and y, and then 1 3 1 3 is somewhere here, and 3 1 3 1 is somewhere here, right? So this is what, this is the given data to us. Now what we want to do, we want to do the prediction. What kind of prediction we want to do here? We want to predict, for example, if new person comes and he puts the value of x as 3.5, the question is what will be the value of y. This is what we need to predict, right? That's why we are doing all these things. So here, this red points, these red markers are showing you the current data, right? Now question is, if the value of x is 3.5, what will be the value of y? So for that, what will we do is, we are going to draw a straight line. Now how to draw a straight line? So for drawing a line, you know that we require at least 2 points. So what we will do is, the first point will be x bar and y bar, that is 3 3. So 3 3 is going to come where? 3 3 is going to come somewhere here. And what is another point? Another point is nothing but y-intercept value, that is 2.1. So 2.1, for example, it comes somewhere here, right? Now we got these 2 points, so we can go and we can draw a line which can pass through these 2 points. Assume this as a straight line, right? So this straight line is called as line of best fit. This is what we are going to make use of, or best fit line. Now, if someone says that if the value of x is 3.5, what you can do is, you can go and you can draw a line like this and you can predict the value of y, right? So somewhere 3.2 3.5 it is going to be. So now you can go and you can predict for any value of x, you can predict any value of y, right? So this is called as line of best fit. Line of best fit is a line which is going to pass through dense area where there are a lot of points. Or I can say, see, this red point is the original data, original value of y for corresponding value of x, and this one is the predicted value of y according to our model. So the difference between them is nothing but error, right? Or the term which is used for that is residual. Okay, so remember this, and our target will be what? Our target will be to minimize that error. So this is the error, right? This is the error, this is the error, residual, right? And many times you will say that there is a formula to calculate the residual actually, which is nothing but predicted value minus original value whole square. So something like this, summation of y minus y cap, right, whole square. So it is actually under the root divided by n minus 2. So y is the original value, y cap is the predicted value, and n is the number of records. So why this square is actually taken? Just to nullify the effect of negative values. Because see, here you can say that the original value of y is 3, for example, and predicted value is 2, right? So what we can get is 3 minus 2 is 1. But here original value of y is 4 and predicted value is suppose here it is 3. So 3 minus 4 is minus 1. So just to nullify the effect of null value, that square is actually taken. Nothing else. Okay. So my point is that this is called as line of best fit, and line of best fit is the line which we are going to make use of in linear regression. Right? So this is how it can be drawn. The concept behind drawing the line of best fit. I hope everyone is clear this till this particular point. Now see what I will do. I will show you the implementation of linear regression with some problem statement. So we will, as I told you that I'll be developing, I'll be showing you application, right? Where we are going to, and that application we are going to deploy it onto cloud. So what is that problem statement? Let's try to discuss first. Directly, what I will do, instead of discussing, generally see what I do is I go and I discuss some concepts like hyperparameter tuning, what is p value, what is hypothesis testing, and all these things. But right now I will not discuss the theoretical points. I will directly move to the hands-on, and then let's see if you have any problem. Then we will try to cover those things also. Right. Before that, what happens in machine learning? If you are going to develop a machine learning model, maybe it's a classification model, whether it's a regression model or prediction model, whatever it may be, there are certain steps which are followed, right? So this particular life cycle, this particular diagram is actually showing you a generalized life cycle of machine learning models. What happens here? So you can see, let me just give an idea about it. You can see that The first and the foremost thing is a data selection. Right now, data can be selected from any source. The source can be in a database. The source can be in a CSV file, Excel file, text file. It can be a database like MySQL, Oracle, MongoDB. It can be Hadoop, anything. Even it can be some messaging technique like Kafka. Right. So a lot of sources are available. So the first and the foremost thing is to collect the data. Right. Once you get the data, then only we can go and we can actually start the work, because without data nothing is possible. Right. Once we have fetched the data, once we have ingested the data, then there is a need to understand the data. So whether it's R or Python, as I have seen that in previous sessions we have learned about machine learning with hands-on sessions with R. So you might have used something called as summary method in R, right? Similarly, in Python we have something called as describe. So what describe method does is, describe method is going to show you what is the count of the number of records in each and every column, right? What is the what is the mean of that, and what is the standard deviation, all those things it is going to show you. We will see that. So data description is just done just to understand everything about the data, or just to understand the features of the data. Whenever I say features, I mean to say columns or attributes. So it is nothing but a story of data, what data is all about, and the features present in the data. Features are nothing but what, as we are talking about supervised learning approach, so I'm assuming the data set is like this, where we have input features and where we have output features. You might be knowing that input columns or input features are called as attributes or independent columns, and target column is called as dependent column or label or output. Right? There are different names which are used for that. So data description. So here, for example, my complete data is in this variable as a data frame, right? So it is in data frame data. Now what I can do is I can apply a method called as data.describe. Data.describe is going to give me a lot of idea about that particular data. So once we have understood some basic things about the data, we can go and we can make use of some statistical and graphical analysis. So here we can make use of, so see, for data selection, you know how to fetch the data. Here we can make use of the packages like NumPy, which are available in Python. We can make use of the packages like Panda. I'll be showing you that. Okay. So for performing statistical analysis, definitely you can make use of NumPy. You can make Matplotlib. Okay. And there are other packages also, like Seaborn is there, even Cufflinks is there. So a lot of packages. Generally, what we do whenever we also develop projects, we make use of Matplotlib and Seaborn. That's what I have used in this particular example. Once that is done, once you have understood about the data distribution, once you have your data in correct format, then there is a need to transform the data, or data transformation and derivation of new attributes is necessary. So sometimes what happens is, sometimes there are some columns which are not needed. So what we need to do is, sometimes we need to go and we need to just ignore those columns or attributes, or sometimes it is a need that we need to combine two columns and come up with a new column, right? Because there is a reason. There is something called as multi-collinearity. So what is multi-collinearity? You might be having an idea about that. Multi-collinearity means what? An independent column should not be dependent on another independent column. See, if if dependent column is dependent on some independent column, that is okay. But an independent column should not be related to another independent column. Right? So if it is like that, then it is called as multi-collinearity. And multi-collinearity should not be present in your data. If it is, then you will get the model definitely, but your model is going to be overfitted model. And what do you mean the overfitted model? Overfitted model is the model which is going to give you good accuracy at the time of training. Maybe for example 95% of accuracy it will give you for training data, but for testing in real time it might give you less accuracy, maybe 75% or 80%. That kind of a model is called as overfitted model, and we do not want overfitted model, and that's why it is really necessary to go and to check for multi-collinearity. How to check for multi-collinearity practically, that I will show, right? But be clear with the concept of multi-collinearity. That is nothing but what? I will again repeat, multi-collinearity is nothing but an independent column depending on another independent column. At the time of implementation, I will give you a proper example for that. Okay. So once you have checked that, okay, so if there is a multi-collinearity, that can be removed with only with one column. What is the one column? For example, two columns are multi-collinear. Two columns, they are having collinearity with each other, independent columns. What you can do is instead of those two, you can do one column, right? That is nothing but deriving a new column if necessary, right? After that, once everything is done, then select the proper algorithm according to the problem statement. If it's a, see, as I talked about supervised learning approach, right? I told you that there are different algorithms which can be used to solve different problems for with the help of supervised learning approach. So with the help of supervised learning, you can actually solve the problem of regression. You can call it as prediction, where you need to predict, or you can go and you can solve the problems of classification. Whenever I talk about regression, there are different algorithms which can be used. For example, here we are going to talk about, we talked about linear regression, right? But it's not like that there is only linear regression. There are other algorithms like decision tree. Under decision tree, there is something called as random forest, which is one of the best algorithms, right? Then there is algorithm called as card classification and regression tree, which is also with the help of decision tree. There is one more best algorithm, which is called as queen of machine learning algorithms, and that is called as XGBoost algorithm. And in practical scenario, many times we prefer this XGBoost, extreme gradient boost. Okay, those who are aware about the concept of gradient boosting, they might be aware about this particular algorithm. So extreme gradient boost can be used for regression. There is algorithm called as neo-based, there is algorithm called as KNN, there is algorithm called as support vector machine, and so on. Generally, I talk about 17, 18 algorithms which are available for solving these kind of problems. Similarly, as there are algorithms for regression, similarly there are algorithms available for solving the classification problems. For example, one of the basic algorithms for solving the classification problems is logistic regression, right? So logistic regression can be used for classification. Decision tree can be used for classification as well as regression. Then XGBoost can be used for both classification as well as regression. And many times you will see that KNN is preferred for classification types of problems. Support vector machine can be used for that. PCA algorithm is there, but PCA is not going to give direct output if the purpose is actually different. But yes, principal component analysis is also one of the algorithms which can be definitely used, right? And even you can go and you can make the Yogesh algorithm and some other algorithms. So here I'll be showing you this particular thing, but remember that it's not like that there is only linear regression. There are other algorithms also. So this step is talking about what? This step is talking about selecting the proper algorithm as per the problem statement. But let me tell you here itself why there is a need to know about all the algorithms. Because in real time, what happens is we do not develop the model only with one algorithm. I told you we generally make use of 6 to 7 algorithms in only one module. Whenever we talk about solving the problem statement, we actually make use of 6 to 7 algorithms instead of one. And whatever is the best out of that, that we choose. That's what happens in real time. So in the end-to-end project, I will show you that. Okay. So selecting the best algorithm and performing the EDA. EDA is nothing but what? Exploratory data analysis with the help of graphs and with the help of stats. Okay. So once that is done, before applying the algorithm, you need to make sure that your data is standardized and it is normalized. I hope you people are already aware about standardization and normalization. So standardization, for standardization in Python, we make use of one package that is called as standard scaler. That's what I have used in this particular example. So what this is going to do is it is going to scale down all the values of the columns or all the columns the same scale, so that it should not happen that a particular column will be given higher weightage as compared to some another column or attribute or a feature. Because what will happen because of that, if your data is not standardized, again your model can be overfitted model or biased model, right? So that's what we do not want. That's why you need to make sure that your data should be standardized. How to get that? That I will show you. Normalization. So you might be knowing about normalization. There is something called as skewness in the data. So see which data is normalized data. So for example, for this what we are going to do, we are going to see the distribution of the data. If the distribution of the data is something like this, right? It is something like this. So this type of data is not normalized. This is called as skewed data, and this is called as negatively skewed data, right? Or I can call it as left skewed data, negatively skewed or left skewed. So if your data is skewed, you cannot go and you cannot apply the algorithm directly. Another thing is your data distribution can be something like this. Okay, something like this. Again, this is skewed data. This is positively skewed data or rightly skewed data. Again, we do not make use of this kind of a data for developing the model. Positively skewed or rightly skewed data. What we need is we need symmetrical data, and symmetrical data, it looks like this, a bell-shaped curve, right? So this type of a data is symmetrical. It can be divided into two parts equally, this one and this one. So this is called as normalized data, right? But see, what do you mean by normalization? So where you have mean, mode, and median representing the same point. What I'm talking about? Mean, mode, and median, right? I hope everyone is aware about this. Mean is nothing but the average value. Mode is nothing but the most repeated value, right? Or the value for which the frequency is highest. And median is nothing but the middle value. So this is normalization. And there is a more thing that is called. So here in this case for normalization, what happens is mu is 0. That is mean is 0, and standard deviation can be some value, 1 point something, 2 point something, or so. But there is something called as standard normal distribution. See, this is normal distribution. There is something called as standard normal distribution, and always remember, standard normal distribution is always centered around 0, where mu is also 0 and standard deviation is 1. This is called as standard normal distribution. So what is standard deviation? Standard deviation is nothing but how much the values actually deviate from the mean. That is called as standard deviation. Always remember, for standard normal distribution, this is the condition. Mu is 0, that is mean is 0, and standard deviation is 1. Right? So I'm expecting you are aware about what is mean and what is median and what is mode and what is standard deviation. So that's what this particular step is actually talking about. That your data should be standardized and it should be normalized. So we are going to do that. Once that is done, go and divide your data into training and testing. Here what we do, here we do it like this. You have the data, right? You divide that data into input and output, for example x and y, right? This input data will be divided into training, right? So x train and so this is the input data, right? X train, x test, and this will be divided like this: y train and y test. This is how your data is going to be divided. So what happens is, this is the input data. For example, I have column 1, column 2, column 3, column 4, and column 5. So till column 4 are independent columns, and column 5 is our target column. So what happens is, all the input columns or independent columns will be assigned to x, and output column will be assigned to y. That is C5 in our case. So this data will be divided into this particular variable: x train, x test, y train, y test. So x train is going to be what? These are going to be the input columns, and corresponding output of that is going to be this one. And x test is again input but for testing data. Y test output but for testing data, right? So based on this x train and x test, we are going to create a model, right? And this model will be tested, sorry, based on this x train and y train, we are going to create the model, and this model is going to be tested with x test data. So whatever the result you are going to get, that will be your prediction, and then you are going to compare the original value and the predicted value, and the difference between them is going to be error or the residue, and our target is going to be to minimize this error, right? That's what is going to happen here in case of training and testing. After that, once your data is divided into training and testing, then the actual model training is going to start. So we use a method called as dot fit in Python. And then to check the accuracy, there are some statistics which we are going to make use of here, like R square statistics, adjusted R square statistics, and they are going to give us what is the accuracy of your model. And if the accuracy is low, we are going to make use of something called as hyperparametric tuning, which is used to increase the accuracy of the model. And then finally, we are going to save the model with dot pickle extension. Or your machine learning models can be saved with dot .scv extension. So always remember, machine learning models can be saved either with dot pickle extension or with dot .scv extension. That's what we are going to do in our case. And finally, we are going to deploy that particular model onto the cloud. And once that is done, if there is a need to retrain the model, that's what you can go and you can decide about retraining approach, right? And logging and monitoring. So this is what happens in machine learning life cycle. Okay. So what I will do, I will directly jump to the problem statement because we want to implement that. Okay. See, all those things, whatever I talked about, actually I explained all those things in detail. If you people need all these notes, definitely I will share with madam, and definitely you can have that, no problem. Okay. So all the mathematics, whatever is needed, is actually explained here. But let me directly move to the problem statement. So, and because I want to show you a model. Yeah. See, first of all, what I will do is I will show you a data set which is available to us. Okay, let me go to my current working directory and let me show you a data set, and uh, then we will implement here. See, in my case, for implementation, what I will be doing is, in my case, I am using these two tools. I am using Anaconda's Jupyter. This is the first thing I am going to make use of. Okay, whatever you are able to see is Jupyter. And one more thing I am going to make use of is ID, and that is nothing but PyCharm ID. But let me tell you, if you do not want to make use of these tools, no problem. You can make use of other things like Google Colab is there, like Jupyter Lab is there, and so on. Spider is there. You can make use of whatever the code I'll be sharing. That code can run in any of this with the help of any of these tools. Jupyter is a notebook. PyCharm is an integrated development environment, and that's what we use in real time for creating the models, right? So in my case, I am using Jupyter and PyCharm ID. Okay, just to make you the things clear. Okay. Now let me go to the working directory and let me show you the data set. So this is my folder of linear regression. See, this is what our folder, this is what our data is. This is a CSV file, comma separated by. Let me open it. Okay, so now I am going to show you that how the implementation steps, all the implementation steps I'm going to show you for the model. Now see, let me tell you what's the problem statement is. The problem statement is like this. You know that whenever, right, maybe for foreign universities or maybe specifically for MS, so you need to appear for some exams. Like there is an exam called as GR, right? There is an exam like TOEFL, right? And there are some other criteria. So all these things, GRE score, TOEFL score, there is something called as university rating, the university from which you have completed your post graduation or graduation. Again, what you need is something called as statement of purpose, right? Whatever the published statement you have, right? So statement of purpose you need to present. That also carries some marks. Letter of recommendation from your guide, from your principal. CGPA is nothing but the marks which you have scored, and whether you have done some research earlier or not. Right. So see, GRE score, TOEFL score, university rating, statement of purpose, letter of recommendation, CGPA, and research done or not. All these are our input columns or independent columns. From these, what we want to predict is chance of admission of that particular person. What is his chance to get the admission in foreign university? For example, the chance of the first person is 92%, second is 76, and so on. So that chance we want to predict. So this is going to be our target column. Okay, try to understand the problem statement. All these are our input features or input columns, and this predicting the chance of the admission is going to be our target feature or the output of the dependent variable or the label. Now, generally, GRE score you might be knowing it is out of 340. TOEFL score is out of 120. University rating is on the scale of 1 to 5. Statement of purpose 1 to 5 out of 5. Letter of recommendation out of 5. CGPA is out of 10. And research done or not, yes or no. So this is a categorical column. Okay, it's not a continuous column. It's a categorical data. 0, 1, yes, no. So it's a categorical data. And again, this is a continuous column, chance of admission. This is our target. So try to understand what we want to do is we want to train such a model. We want to come up with such a model where suppose if someone comes, so if someone has got out of 340, someone has got 301 marks in GRE. Out of 120, someone has got 112 marks in TOEFL. University rating is 4. Statement of purpose suppose 4. Letter of recommendation suppose 4. CGPA suppose 8. And he has done some research. Suppose what? So yes means 1 and no means 0. Okay, because the basic need of any machine learning algorithm is that your data should always be in numerical format. Always remember. That's why I'm writing it down as yes or no, like 1 or 0 respectively. Okay, so you need to predict. Your model should be able to predict what will be the chance of the admission of that person. This is what our problem statement is. Okay, I hope everyone is clear about this particular about this problem statement. So we want to come up with such a model, right? So I will show you first of all how to create the model. Then from that model, how to come up with a web application by using some frameworks. This is what we are going to do now. Okay. Now try to see the data. Just try to understand here. If you just check here, first column is what? First column is serial number, and obviously serial number is not going to contribute anything to the chance of admission. So obviously we are going to drop it. That's what we are going to do. Next is GRE score. Now you can see in GRE score column, first person has got 337 marks out of 340. Second person has got 324 marks. But third person, if you go and if you try to see, it is blank, right? So in previous sessions, you might have learned about something called as missing values, or NA values, or NaN values, or null values. All those things are one and the same. So we need to handle those values. So see, here also missing, here also it is missing. So it means that in GRE column, GRE score column, there is a problem. Similarly, there is a problem in TOEFL score also. Sorry, university rating also. University rating is out of 5. Is there any problem in TOEFL? We will find out that. So we need to check for missing values also. So GRE score, all these are values. TOEFL score, these are the values. University rating, there are some missing values. Statement of purpose, letter of recommendation, CGPA. Just check it and just check the research column. 1 means he has done the research and 0 means that person has not done the research. Right? This is what we are going to assume because I told you maybe from the client you will get it as yes or no, but ultimately that should be converted into uh, numerical data. Maybe you might be aware about something called as label encoding. So you can make use of those methods to convert your categorical data into numbers because that's a basic thing. Always remember, whenever you are going to apply any algorithm in machine learning algorithm on any data, first and the foremost thing is that your data should be in numerical format, right? Next thing is that your data should be normalized. I told you what is normalization in a short. Your data should be standardized. These are the basic requirements before applying any machine learning algorithm, right? So that's what we are going to take care. And finally, we need to predict what will be the chance of admission of that person to get the admission into foreign university. I hope everyone is able to understand what is given to us and what are we going to do now. Right? Obviously, this serial number we are going to draw finally. So this is what our data set. Now I will go to Jupyter, okay, and I will try to show you how are we going to approach to create a model. Okay. So the first and the foremost thing is I'm going to import all the necessary packages. What are we going to need? So you are already aware about pandas package. Pandas package is used to fetch the data to read any file. In our case, our input data is in CSV file. So we are going to need pandas package to read the data from the CSV file into data frame in some variable, right? NumPy package is used to convert anything into array. So that and for statistical, for calculating different stats, we are going to need this. That's why we have imported it. Right? Import NumPy as NP. PD and NP are both alike. They are called as alike. Just another name for NumPy and pandas. After that, from sklearn. So sklearn is a, again you might have heard about sklearn. Scikit-learn it is. It's a package available in Python in which we have almost all the algorithms available for which are required for machine learning. Right? So scikit-learn.preprocessing. From this I am going to import what? I am going to import standard scalar. If you people remember, at the start I told you that we are going to make use of standard scalar. This library we are going to make use of, this method we are going to make use of just to standardize our data. Why? I already told you. If your data is not standardized, right, your model is going to become a biased model. Right? That means it is going to give you a particular kind of a result again and again, and that's what we do not want. Another thing is sklearn.linear underscore model. Right now, don't worry about this reach cross validation, elastic net cross validation. Don't worry about this because I did not discuss it. If you know it, that's good. Okay, but as we have limited time, that's why I did not discuss these concepts here. What you understand from this is from sklearn.linear underscore model, we are going to import linear regression. As I told you that in scikit-learn or sklearn, almost all the algorithms are available. So here, as we are going to make use of linear regression algorithm, I am just going to import this particular method, right? So whatever the steps I have shown you to draw that particular line of best fit, right, and to predict the value of the output variable or the target variable, all those things actually you don't have to worry. Linear regression method is going to take care for that. Okay, so and that is present in scikit-learn. This is how we are going to import that scikit-learn.linear underscore model. After that, what scikit-learn.model underscore selection train test split. So train test split is the method which we are going to make use of to split our data into training and testing. The same way which I had told you earlier. Stats model, we are going to calculate some statistics like what is p value, what is f1 score, what is r square statistics, what is adjusted r square statistics. So r square statistics for now you can take it as accuracy of your mind. Okay, this is this package, this particular method which we are going to make use of just to know how my model is actually performed. Is the accuracy more than 90%, less than 90%, or 80%, or whatever? It is going to help. Matplotlib is a package available in Python which is going to help us to plot different types of graphs. The same is the case with Seaborn. So generally, what we do is we use a mixture of Matplotlib and Seaborn. Right? It all depends on individual. One can make use of other libraries also that are available in Python. So in a short, all these things are nothing but the necessary inputs for developing the model. Next thing. Okay. So see, whatever you are able to see here, this is just a function. And what this function is doing here, this function is calculating some statistic. And what is that statistic? That statistic is called as adjusted R square statistic. Right? So the formula of adjusted R square statistics is something like this: 1 minus R square statistics into n minus 1 divided by n minus p minus 1. I will tell you what are all these. This R square is called as R square statistics, which is by default present in R. For now, as I told you, you take it as accuracy of your model. Okay, but there are some limitations to R square statistics. What is that limitation? So the limitation is like if you go and try to add more and more columns in your data set and try to see the accuracy, accuracy will increase if you go on adding more and more columns. But those columns might be contributing to the output or might not be contributing to the output. So that's the problem with R square statistics. And that's why we use something called as adjusted R square statistics. And this is how adjusted R square statistics is actually calculated. And that's what we have actually used here. It is just a function with the help of which we are going to calculate the adjusted R square statistics. So this is the definition which we have written in Python to calculate the value of adjusted R square statistics. It is just a straightforward formula which I have already mentioned in my notes. Right? So if you people are interested, once you get all these notes, you can go and you can refer it in the above sections. Definitely you will get that. Right? So for now you can understand R square and adjusted R square are the statistics which we are going to make use of to understand how our model has actually performed. Right? That is the use. Now the first step is a data fetching. So what am I doing? I am using pandas package pd.read_csv. What is this admission_prediction.csv? This is the CSV file which I have shown you earlier, right? This particular CSV file, admission_prediction.csv, is the file which I have already shown you, right? And I hope you have everyone understood the data. You see, admission_prediction.csv. So we are just trying to fetch that particular file. We are just trying to get that particular file from my current location. That's why I did not give the complete path because I am already in that particular directory where this particular file resides. That means now everything, whatever was there in this admission_prediction.csv file, whatever was there, now it is in this particular variable. If you go and if you try to see this particular file and try to see how many number of records are there in the CSV file, you can find out that there are nearly 500 number of rows or observations or records in this file. Again, 500 is not a big number, right? Because if I would have taken a very huge number of data sets, it would have taken a lot of time to model, right? So, but yes, in this case, we are trying to make it a 500 number of rows. Close this file. That means what? That means in this data variable, all those 500 rows are going to be fetched. So you can see data dot head command, you might be knowing head command by default shows you first 5 rows in R, and in Python it shows in first 5 rows in Python, and in R it shows you first 6 rows. Head command is actually taken from basic Linux commands only. You might be knowing that in Linux head command shows you first 10 rows, 10 records. So in R, in Python it shows you first 5 rows, right? So you can see serial number is there, GRE score is there, total score is there, university rating is there, statement of purpose, letter of recommendation, CGPA, research done or not, and chance of admission of that person. So everything is important. Try to understand. Okay, we are able to see only 5 records because we are using head command. That's it. Otherwise, everything is there now in database. After that, so this is what I was talking about. Data dot describe. So what it is going to show me now? Check. So this is what we are doing. Next step in a particular flow diagram. If you remember, see, describe command is going to show me the count of each and every column. So how many number of records are there in serial number column? 500. Yes, that's correct. Yes, now I show you that in your CSV file there are 500 number of records. In GRE score, how many number of observations? 485. So why it is so? Why there are no 500 number of records in GRE score? Because as I showed you the data earlier, if you remember, there were some missing values, right? And count function by default always ignore null values or missing values. That means there are near about 15 missing values which are present in GRE score column. And that's why the count of GRE score is not 500, it is 485. Similarly, in 490 is the count for total because that means there are 10 NA values or missing values present. In university rating, again missing values are there, 15 missing values are there. SOP correct, LOR correct number of observations, CGPA correct, research correct, and final column, that is output column, chance of admission, correct number of records are there. So describe command shows you in which columns there are missing values or not, right? In which column there are missing values. Mean is nothing but what? Mean. So this is the mean of the CGN number, mean of the GRE score, average. Mean is nothing but the average. And same thing for us. This is nothing but what? Standard deviation. I told you, standard deviation is nothing but what? Standard deviation is nothing but how much the values deviate from the mean value. How much all the other values deviate from the mean value, that is called as standard deviation. If you are not clear about it, don't worry, maybe you can refer this file later on. But those who are aware about it, I think they will understand. Right? That's good. Uh, Another thing is what is the minimum value from this column, from this column, from this column, and so on. What is this 25%, 50%, 75%? Actually, they are percentile. Okay, so this is quartile 1, this is quartile 2, quartile 3, right? There is, and I can otherwise say it like this: 0 percentile, 25 percentile, 50 percentile, 75 percentile, and this is 100 percentile. I hope you are aware about quartile 1, quartile 2, quartile 3, or the general term we can make use of for this one is percentile. Okay, now this is quartile 1, 25 percentile, quartile 2 is 50 percentile, quartile 3 is 75 percentile. Now to understand this, one should know the concept of percentile. For example, if I say 25 percentile of GRE score is 308, 25 percentile of GRE score is 308. So my question to you people is that how can you interpret it? Can anyone just let me know, maybe in the chat box, if you are not able to unmute you? Can anyone just let me know what do you understand by this percentile? Uh, I hope you people got my question. Anyone can anyone just let me know if 25 percentile of GRE score is 308? What do you understand by that? That means I am asking you what do you mean percentile? What is the meaning of percentile? I think someone has raised hand. Nokia 8. Can you just type the answer in the chat box? I hope everyone got my question. Someone is not able to understand the question or miss the question, just let me know. Yeah, Mr. Krishnakant Hallika.
From my understanding, it means that 25% of people, we are above 25% of people. If you have 25 percentile. For example, if you have 95 percentile, then that means you're above 95% of the people who attempted the test.
Okay. Okay. Or in other words, I can tell it like this. See, if 25 percentile of GRE score is 308, that means there are 25 percentage of the people, right, who have scored less than or equal to 308 marks in GRE. There are 25 percentage of the people. Now, how many number of records total? We have 500. So, if I say 25 percentage, right, it means what? So, out of 5, 25% of 500, right? That means 25 5 of 125. That means there are 125 people who have scored less than or equal to 308. That is the meaning of percentage. Similarly, 50 percentile. That means there are 250 number of people who have scored less than or equal to 317 marks in GRE. That is the meaning of percentage. I hope everyone is able to understand that. Okay. So what describe is giving us is it is giving us all these values. Quartile 1, quartile 2, quartile 3. So percentile actually divides data into 99 parts, and quartile divides data into 4 parts. That is the main. So this kind of information you get just with the help of describe command. So and I think as we have done with our hands-on, you might have used something called a summary. Right? Something similar to that in R. Okay? I hope everyone is able to understand that. So the main point here we should notice is that there are some missing values in GRE score, TOEFL score, and university rating in our case. Now our job is to handle those missing values, and that is what we are going to do now. See, university rating, TOEFL score, and GRE score. So from data, this is nothing but what? This is the indexing, simple indexing in Python. So data of university rating is equal to data of university rating dot fill NA. Fill NA is the method which we use to fill the NA values, right? But filling NA values with what value? So with data of university rating dot mode of 0. Now I told you, what do you mean by mode? Mode is nothing but the most repeated value. Now why are we replacing the missing values from university rating with the mode? Why not with the mean? Because university rating is either 1 or 2 or 3 or 4 or 5. So it's like a categorical data. So always remember, whenever we want to replace or whenever we want to handle missing values, handling of missing values, we actually call it as imputation. Okay, so whenever we are going to do imputation, what we do is, if there is a categorical data, for categorical data we always use mode of that particular feature, right? And this is kind of a categorical data, 1 2 3 4 5 categories. There is no other value other than 1 2 3 4 5 for university rating, because university rating is on the scale of 1 to 5. That's why, and that is the reason why we are making use of dot mode, right? So mode is nothing but what? Most repeated values. For example, uh, you might be knowing, right? Suppose if I have the values like 1 2 3 4 4 4 5 5, what is the mode of this? Mode of this one is 4, because 4 is repeated most number of times. So the value which is having highest frequency, most repeated value is nothing but the mode. That's what we are doing, because it's a categorical kind of data. You can check for TOEFL score. TOEFL score is not a categorical data. That's why we are replacing the missing values from the TOEFL score with the mean of the TOEFL score column. And mean is nothing but what? Average. And same thing we are doing it for GRE score column. So here we have done imputation. This step is called as imputation, right? I hope you people are able to understand that. Once that is done, we again go and we again try to check data or describe. Now this time if you go and if you try to check the count is 500 for each and every column. You can check it, right? Because why? Because we have filled the NA values, we have done the imputation, so there is no question of missing value here. We have successfully handled the missing values, so we are good to go now. The missing values are actually handled properly. Next thing, as I told you that there is a column called as serial number, and obviously serial number column is not going to contribute anything to the chance of admission of that person. So what are we going to do is, from the data we are going to drop it. So data dot drop is the method which we are going to make use of to draw the serial number column. Why? I hope you understood that, right? So now in our data, what do we have? We do not have serial number. So except serial number, all the other features we have in our data variable. Okay. Next thing is, now we will see how our data is distributed. Why are we going to see the distribution of the data? If you remember, I told you the basic requirement for the machine learning algorithm is that the data should be normalized, right? If your data is not normalized, if it is having some skewness in the data, your model might become overfitted model, and we do not want overfitted model. And that's why your data should be normalized, that is symmetric. And that's why, first of all, what we will do, so what these lines of code are doing, it is just to plot the graphs for each and every feature in the data set. For example, what are we going to make use of? We are making use of matplotlib. So distribution plot I am going to make use of matplotlib and seaborn. So SNS is nothing but what? Seaborn package. So SNS is nothing but what? Seaborn package. So what we are going to do is, we are going to for column in data, if plot number is less than or equal to 16, right? So obviously this many number of plots we are going to get, right? 1 2 3 4 5 6 7 8, right? So what are we doing? We are using a method which is available in matplotlib. Subplot is the method which is available in matplotlib, with the help of which we can actually go and we can divide the canvas, the area available into different areas. So that simple thing is, we are just plotting a distribution plot to see the distribution of the data, right? So what we found out here is, we can find out that, let me just a minute, someone is writing on the screen. Okay, I think I have access, no problem. So what we can do is, we can observe here how each and every feature is distributed. So for example, if you look at GRE score, now see, in GRE you can find out it is okay. It looks normalized in the data. There might be some skewness, but that's okay. This is also somewhat okay. It looks like this because it's categorical kind of data, 1 2 3 4 5. But again, somewhat what you can say, normally distributed. There is some skewness here, but not to worry that much. It all depends. If you go and you can apply, you can actually try to remove the skewness. That's possible. But if you look at all these distribution plots, the distribution looks decent enough, and there doesn't seem to be any skewness, right? How to remove the skewness? So for that, actually we have something called as, you can go and you can actually make use of box and whisker plot, and you can find out the outlier values, and you can ignore the outlier values or extreme. That's what you can actually do in this case. So as data looks decent, what you can do is, now we can go and we can divide our data into input and output. So naturally, what we do is, we try to assign all the input columns to the x variable and y variable to the output to the y variable. But again, it's not a hard and fast thing. So what we are going to do is, from data, chance of admit, which is our target column, which is our output column, that column we are going to assign it to y variable, and accept that is data dot drop columns is equal to chance of admit. So accept chance of admit, all the other features we are assigning it to x. That means what do we have in x? In x we have GRE score, TOEFL score, letter of recommendations, statement of purpose, CGPA, and research done or not. That is all the input features. And in y, what do we have? In y we have chance of admit. That is our output column or target column. After that, what are we going to do is, we are going to again make use of Seaborn and Matplotlib package just to see the relationship between input and output columns. So here we are going to make use of a scatter plot from the Matplotlib. Okay. So let me show you how to interpret all those plots. See, I am not discussing this code here because I am expecting that you people are already aware about the packages like Matplotlib and NumPy and Pandas and Seaborn. Okay. It is just the plotting of the graph. So from this graph, what you can interpret is, now see, chance of admission against GRE score, chance of admission against TOEFL score, and chance of admission against university rating, and so on. You can see that as the GRE score increase, obviously the chance of admission of that person increase. So this is somewhat linear. Again, as the TOEFL score increase, chance of admission is going to increase. Again, somewhat linear. In this case, you are able to see this kind of a graph because this kind of a data is categorical data. But again, it is somewhat linear. right? So you can notice that most of the times you will see a linear relationship between all the input variables and the chance of admission, that is output variable. So here you can see that chance of admission against segment of purpose somewhat linear, letter of recommendation and CGPA obviously, and that is true, right? If your score is higher, if you score higher marks in your graduation and post graduation, definitely your chance of admission is going to be higher. So linear relationship in short I can say. So overall what we can say that we can see the data in which we have linear kind of a relationship. See the relationship between the dependent and the independent variable, that is input and output variables, or input and target variable, looks fairly linear, right? And thus our linearity assumption is satisfied. So that is one hint kind of a thing you can say. We can go and we can make use of linear regression. After that, what? So if you people remember all the steps which I have shown you at the start of the session, that particular flow diagram, there was something called as standardization, right? So at that time I told you that I am going to make use of a method or a function here that is called as standard scalar. What it is going to do? It is going to standardize my data. See, what happens is, as I told you that we have different features. Like we have GRE score, this is one feature. We have profile score, right? Then we have statement of purpose, letter of recommendation, then university rating, and then we have CGPA, and then research done or not, right? So I told you GRE score is out of 340. Suppose someone has got 320. Profile score, so this is out of 340. Profile score is out of 120. Suppose someone has got 112. Segment of purpose 5, CGPA 10, and this is done or not 0 or 1. Now you can see that if the values are like this, okay, so you can see this value is very much higher as compared to these values. So what will happen while training? It might happen that algorithm might give more importance to this column, more weightage to this column as compared to other columns, right? And that's what we do not do. If it is like this, that means your model might become a biased model. Now, what do you mean by biased model? Again, that is also explained in all these notes in the previous in the above section, which I did not discuss. Okay, biased model, and that might lead to overfitted model. And that's why what we will do is we make use of some methods like standard scalar. What this is going to do, for example, let me give you an example. Maybe what it will do is it will apply same operations on all these columns. Maybe for example, take the square root, take the square root of this, take the square root of all this, right? And square root of 300 you will get some value. Again, go on taking the square root. So go on taking the square root again and again. Go on taking the square root again and again till all those values come to the same scale. So maybe suppose if the square root of after taking the square root of all these values again and again for all the values of this column, same is the thing, or maybe square root or log, whatever you want. So the purpose is just to scale down all the values so that all the columns should be at the same level, or the difference between them should be as less as possible. Sir, can you just mute? I think someone is there by mistake. Yeah, thank you, sir. So it is just to bring all the values to the same scale or scale down the value so that difference between them should not be that much. And each and every column will be having the equal value. So what are you doing is I am calling this particular method, creating the object called as scalar, right? And what it is doing, scalar dot fit dot scalar dot fit underscore transform. Transform what? X. What is this X? This X is nothing but all our input variables: GRE score, profile score, statement of purpose, data of recommendation, university rating, research done or not. So we are just trying to scale down those values and we are storing it in a variable called as X underscore scale data. Right? If you want to see that how it looks like, it will be just numbers. It is not going to make any sense, or you will not be able to understand it. It is just numbers, but numbers in such a way that the difference between all the values will be very, very less. So that's what scaling the data is. Once you scale the data, now what am I going to do is, next step is to check multi-collinearity in the data. Now, at At the start, I told you what is multicollinearity. Multicollinearity is nothing but what? One independent column is dependent on another independent column, or one independent column is related to another independent column. That is called as multicollinearity, and we do not want multicollinearity in our model. If it is there, then your model again will become over period. So what happens is, for example, you are going to create a model which is going to predict the salary of a person based on the experience of that person, and maybe based on the age of that person. Now see, if here these are the two input columns or input features, and this is going to be the target column or the output feature, right? Now, as you are saying that you want to create such a model which is going to predict the salary of a person based on the age and the experience, but if you look at this carefully, obviously salary is dependent on experience, yes. Salary is dependent on age, yes. But there is a relationship between these two columns also. For example, if given, so it means that what I want to say is you can calculate the value of age given the value of experience. If you are aware about some constant value, what is that constant value? That constant value is nothing but age of the person at the time of joining, right? If you are aware about this constant value, you can easily calculate the age. That means this independent column is dependent on this, or vice versa also you can say. That's what we do. Collinearity, instead of using two columns, what you can do is you can go and you can try to create only one column. For example, seniority level. So based on the seniority level, so you are going to derive a third column, that is seniority level, by combining these two columns by applying some logic, and from that seniority level, then you are going to train your model to predict the salary. This is how you can actually go and remove the multicollinearity from the data. But in Python, how to detect the multicollinearity? So in Python, to detect the multicollinearity, there is a concept called as VIF, variance inflation factor. What is that? That's what we are going to discuss now. And how to make use of that? That's what I will show. See, from stats model dot stats underscore outliers underscore influence. Okay, this is from stats model. What am I importing? Variance underscore inflation underscore factor. This is the method which we are going to make use of to detect whether there is multicollinearity present in the data or not. If there is multicollinearity, yes, there are different ways with the help of which you can remove the multicollinearity from your data. So what are all these things I am trying to do? This is nothing but I am trying to clean my data. I am trying to prepare my data to create the model. See, everyone can create the model, but we want best model, right? So that's what we are trying to do. So the variance inflation factor, this is how we are going to import it. What am I going to do? X underscore scale. What is this? X underscore scale is our scaled data. I am going to assign it to a variable called as variable. Right? So variable is the variable to which I have assigned X underscore scale data. Now after that, what am I going to do is I want to calculate VIF value for each and every column. For that, what I am doing is I am creating an empty data frame, and that data frame I am naming it as VIF. Now in VIF data frame, I am adding a column called as VIF, and in that VIF, what I am trying to calculate is I am trying to calculate variance inflation factor. What is variables? Just now I told you variables is nothing but all the columns. It is just a variable. I just a variable. So I is going to vary how many number of times? The number of times the number of columns we have. Right? So for all the columns, I hope you are aware about range function in Python. So what it is going to do is variables dot shape of one. I hope you are aware about method available in NumPy package that is called as shape. Shape variable name dot shape is going to give us what? Variable name dot shape is going to give us number of rows and number of columns. So number of rows are first and then number of columns. And as we want number of columns, that's how this one is written. Okay. So variable shape is going to give a number of rows and number of columns. Out of that, we know one number of columns. So this I is going to vary how many number of times? The number of times equal to number of columns, right? So for example, if we have 8 columns, so I value is going to vary 8 times. So what are we going to do? This particular method is going to calculate the variance inflation factor for each and every column. And VIF underscore VIF of features X dot columns. What is X? Input variable. Dot columns is going to give what? Dot columns is going to give the names of all the columns. So it is going to give you list of all the columns, and I am just assigning it to this particular attribute. Now finally, I am going to display VIF. So VIF is going to look like what? VIF is going to be a score VIF and the name of the feature. So what happens is, let me tell you, if VIF value for a particular column, if it is greater than 5, that means there is multicollinearity for that column. So all the values should be less than 5. Okay, that's what we need to check. So this particular data frame which we created here, it is going to have all the column names from the input, all the input features, and their corresponding VIF value. Let me show you. This is how it is going to look like. Now you can check. For GRE score, VIF value is 4 point something. Profile score, VIF value is 3 point something, and so on. So in our case, no VIF value is greater than 5. That means there is no multicollinearity present in your data. If it would have been greater than 5, what I would have done is, I would have actually combined the columns, or I would have directly removed that particular column if there is a multicollinearity, or otherwise I would have applied some techniques like principal component analysis. So this is where PCA is going to come into picture, right? So PCA is actually not going to give you a model directly. PCA is like a pre-processing algorithm many times, right? So in real time also, what we people do is, we make use of PCA algorithm as a pre-processing algorithm, right? So this is what all the VIF values are calculated here. After that, as there is no multicollinearity in our data set, now we are good to go, and we are good to divide our data into training and training data. So next thing what we do is, we use train test method. So see, x train x test, y train y test, and x underscore scale is our input features, y is our output. What is the test size I am putting here? 0.25. That means I want 25% of the data as a testing data, and remaining data, that is 75% data as a training data. So we have 500 number of columns. Out of that, 25%, that means 125 columns will be in test data, and remaining 375, sorry, 375 rows, not columns, rows or observations will be taken for training the model. And again, it is not a hard and fast rule. It can be 70-30, 25-75, 80-20. It all depends on the data. And what is this random state is doing here? Random state is going to give you random values from the input as well as the output. For example, see, y underscore train. So it has given you 378th record, 23rd record, 122 record, 344th record. Why? Because random underscore state is equal to 355. Don't worry about this value. It can be 1045 to anything. It is just a randomness. Okay, so it's not like that. If I have 500 number of records and I'm trying to divide my data into training and testing, so if I divide my data as 25 and 75, right, 25% test and 75% training, it's not like that first 75% of data is going to be in sequence. No, it's not like that. It is random. Corresponding output or a corresponding input, definitely you will get, but everything is random like this. Because that's how it should be trained, right? So this is what our output training data. And similarly, you can go and you can later on try it out, like display the value of x train, x test, y train, y test. So whenever I say y train, so obviously in y train I should get, as it's a training data, 375 number of records I should get total, but they are random. And finally, as I want to create a model, I am going to call linear regression method. So that's it. Even if you are not aware about the logic behind linear regression, still you will be able to create a model with the help of this. So linear regression, create an object of that. That is called as regression. And a regression dot fit. This is nothing but actual training. On the basis of what? On the basis of x train and y train. X is nothing but the input and y is nothing but the output. So on the basis of this training data, here we are creating a model. Now there is a need to go and say, so see, whatever the logic, whatever we have seen in case of linear regression, that is whatever I shown you, that okay, this is how we are going to draw straight line, that's what is going to be your residual or error. Everything is taken care by this particular method. So you don't have to worry. So your job is just in Python, your job is just to call the method, create the object of that, and train the model. Actual training is this based on the training data. That is 375 number of records in our case. Once the training is done, so see, here we are done. Here we are done with the training. Once the training is done, now if you remember in that particular flow diagram or machine learning life cycle which I showed you at the start, the next thing is to save the model. So either you can save the model with .pickle extension, or you can make use of .save extension. I will show you how to make use of this, because at the end I will be showing you a web application which we are going to create for the same model. Okay, so see, what I am doing is I am creating a string right? You know that everything that is in double quotes or a single quote in Python, that is treated as a string. So I am creating a string called as finalize underscore model dot pickle. I am assigning it to this particular variable. Now I want to save my model with this name. So what I do is, my model is what? A regression is my model. So what am I doing is pickle. Pickle is what? Pickle is a package which is available in Python, which you can make use of to save your model, right? The extension is .pkl or .pickle we can say. So pickle.dump is what? Dump is a method. It means dumping is nothing but writing down. So whatever the model which you created, I need to save that model in some file name. And you know that basic file operations are what? Whenever you write, you want to write down something in a file. First of all, you need to onto that file, right? And then close the file, right? These are the operations. So what are we doing is I'm opening that file. Which file? The file in this variable file name. Which is the file in the variable file name? Finally underscore model.pickle. So so simply what are we doing is we are dumping this, we are writing down this particular model in finalize underscore model.pickle. So we are trying to open this file in W means write mode and B means binary mode. Binary means what? Binary means executable mode. So in simple words, I can say that I am just trying to save the model with this particular name. Dot pickle, here you can imagine dot pickle. If you compare it with, for example, if you talk about Windows operating system, so it is exactly similar to executable file, I can say, right? So why are we storing it with this extension? Because if you want to make use of this model further in some other projects, definitely what you can do is you can go and you can directly make use of this particular file. That's what I'm going to show you once we are done with this discussion. Okay, so finally our model is saved. After that, what are we doing? Now here I want to make use of the model. So what am I doing is pickle.load. Whenever you want to load the model, you use a method called as load, which is by default present in pickle. So pickle.load, open the file. Which file? File name. What is assigned to file name? Finalize underscore model.pickle. So I am trying to open that particular file in the read and binary mode. Binary means executable mode, right? So I am saving it where? Loaded underscore model. And after that, loaded underscore model dot predict. As I want to do prediction, that's why I am doing what? I am doing dot, I am using dot predict. Okay. And what are all these values? So I am passing manual input here. What is this 300? This is the GRE score of the person. What is 110? This is the TOEFL score of the person. This is what? Statement of purpose. This 5 is what? Suppose university rating. This is what? Letter of recommendation. This 10 is what? This is the CGPA of that person. And 1 means research is done by that person, right? So we are passing manual values as input to this particular model, right? And here it is going to show us the result. So what is the result? The result is 0.92. That means the percentage of the chance of the admission of that person in foreign university is 92.19% for this if he has scored this type of marks, right? This is what our model is. After that, what I have shown is here, if you go and if you try to see, I try to make use of some statistics just to check the accuracy. So regression.score, what is this regression.score? This is called as R square statistics. So the R square statistics of our model is 84.50% for training data, right? And adjusted R square for our model is 83.85. So there is no that much of difference between them. That means we are on the right path. If there would have been a lot of difference between these two statistics, that means there are some unwanted, unnecessary columns in the model, and we need to go and again repeat the steps whatever we have applied till now, right? So that's what that R square and adjusted R square statistics is for training data. But for testing, if you go and if you try to check the value of R square statistics like regression dot score, it is 0.75. That means 75% is the accuracy for testing data, and adjusted R square is what? 73%. Now, if you want to go and if you want to improve the accuracy, there is a concept called as hyperparameter tuning. So in layman term, if I want to tell you what is hyperparameter tuning is, it is like tuning the parameters of the method in such a way that in earlier days, right, there were radios. What we used to do, we tried to adjust the knob of the radio in such a way that the sound should be clear. Exactly the same thing. We will try here in hyperparameter tuning. What we do is we try to play with different arguments of linear regression method, and we try to improve the accuracy. But I did not discuss it earlier. What is hyperparameter tuning? That is actually again explained in the above sections, right? So that's what I have actually mentioned, right? If we get time, definitely I will come to this point. But we wanted to develop the model, and our model development is done. See, I should limit myself at some of the points because I again need to show you deployment as well as the application, right? That's what I will show you now. So whatever you are able to see, the regularization method and all these things, these are just to improve the accuracy of the model, right? Whatever you are able to see now, this is just to improve the accuracy of the model. So finally, the accuracy of our model for testing data is 0.75. And after that, I have explained in these notes, I explained about polynomial regression also. And below that, I have given the steps to deploy the model. Now, okay, see, I hope till now, you people have got the idea about how we got finalized underscore model dot pickle, this particular file, right? Whatever the model we got. So how are we going to make use of it? See, yeah, this one. Finalized underscore model dot pickle. Now what am I going to do is I am going to make use of this particular file in PyCharm. As I told you that I am going to make use of Anaconda's notebook, that is Jupyter, as well as I am going to make use of one IDE that is called as PyCharm. And that's what we do in real time. Let me show you. Same project. Now I'll be showing you with some user interface. Okay. So here, see, here everything is done. Fetching the data, cleaning the data, exploratory data analysis, I have shown you, and finally we created the model, and even we got the result. Now let me go and try to make use of PyCharm ID, and let me show you application. Okay. So see, same problem statement, but I have used PyCharm, and I will be making, see, if you are able to see here, I will just try to highlight the same file, whatever the file which I have created. Okay, whatever the file which I have created, finalized underscore model dot pickle, this is the file I have used. And this file was present in my working directory, right? Let me show you what was my working directory. So here, this is what my working directory in case of Jupyter. So here, if I go and if I try to check for finalized underscore model dot pickle file, now see, this is where that file is. So what I have done is I simply copied this particular file and I pasted it into this particular folder where I have written some .py program. What is that? I will tell you. So this is the final underscore model.pickle. Proc file requirements.txt file are the files which we are going to require for deployment. And static and templates are the files which are going to help us for front end. And app.py is my main file or the logic or where my logic is. Okay. Now, what I will do is I just open this folder where I have all these files. Okay, I'll be sharing this particular project as zip file. If you want to try it out, you just need to follow whatever I am telling. Okay, same thing you need to follow. What I will do is I will right click and open this complete folder as a PyCharm community edition. It means simply I am opening all those files in PyCharm. That's it. What is PyCharm? Called as VS Code, which is available, or you can make use of this ID also, PyCharm. But most of the times I will prefer PyCharm because there are very good features in PyCharm, right? Now, same problem statement. For that problem statement, here we have created a web application. Now let's see how that web application is going to look like on this local machine. What I will do, I will just try to run that on my local machine first, and then I will go and I will deploy it onto cloud. So let me just close all these things. So whatever you are able to see, this is nothing but PyCharm. I'm just repeating it for those who are not aware about it. Okay. Now see, understand the folder structure. This particular folder is where my project is. Inside that I have folders like static, it's a standard folder. Templates, it's a standard folder. I will tell you what it is. App.py is a folder, is a program, .py program, Python program where I have written my logic. So whatever the code which you are able to see here, that is the code which we have written in app.py, and it is not difficult to understand. I will explain you this code. you'll be able to make sense about that. And finally, underscore model.pickle is the file which I have just now shown, which we got from the Jupyter notebook, right? Where we trained our model. Proc file is procedural file. Requirements.txt file, proc file are the files which we require for deployment. And train.py is again for importing the packages. Right. What I will do, I will try to go reverse way. First of all, I will show you a running version of this application on my local machine. So let me just click here. Always remember, whenever we want to run any project, whenever we want to run any application, maybe for example, web application like this, the first and the foremost thing, you need to make sure that you should have an environment already created. In my case, I have already created the environment. How to create the environment? You just need to go to file, okay, file option in this file menu, and in file, once you go inside file, you go to settings, okay, and in settings you will be able to see something called as project interpreter here, this one, right? And once you click on the project interpreter, you will be able to see this gearbox option here, this one, right? And what you need to do is just go here, click on that particular option and click on add. And once you click on add, you can use virtual environment or Conda environment. If you have installed Python directly, you can use virtual environment. If you are using Anaconda's Python, you can environment with this name, ML for cloud deployment 02 integration white. Whatever name you want, you can go and you can queue that. But in my case, it's already done. So how to check whether the environment is created or not? So you just need to go and click on terminal option. Once you install PyCharm or VS Code or any other IDE in your case, you will see terminal option. I will click on this. So once you click on terminal, it is going to show us this type of terminal. Now in my case, if you people are able to see here, this is the environment name which I have given, ML for cloud deployment 02 underscore LN underscore YPM. You can give any name, 1, 2, 3, whatever you want, right? Now, so environment is the first. Now in my case, environment is created. Now, as I told you, I will be going reverse way. I will directly show you a running version of this. So go to run, click on run, okay, and click on this app. Now what should happen? It should give me a link to run the same application, same project which I have shown. Now see, it is restarting with stats, right? It has given all those things. So it has given us this particular link. Try to understand what is this link. What is this 127.0.0.1? This is localhost. All of you might be aware about that, right? That is the my local machine. And this 5000 is nothing but what? This is the port number. Always remember, by default, any application is going to run on port number 5000. If you want to change that port number, you can change. But in this program, I did not give any port number. That's why by default it is going to make the port number as a 5000. You can use 8000, 5001, whatever you want. Right? So now what I will do is I will go and directly copy this link. Okay, I will copy it. I will open a browser and I will try to paste that and try to hit that. So let me open the browser. Let me open new tab. Let me paste that link here. Okay, and press enter. I should be able to see a page. See, this is what a front end for our application is. Now, what is this? So, GRE score out of 340, I should enter the value. TOEFL score out of 120, I should enter the value. University rating out of 5. SOP out of 5. Letter of recommendation out of 5. CGPA out of 10. And research done or not, that is yes or no. And then click on predict. So you will be able to see the chance of a prediction of a person. Let me show you. Suppose someone has got 315 marks out of 340. TOEFL is out of 120. Suppose someone has got 112 marks. University rating is suppose 3. Statement of purpose is suppose 4. Letter of recommendation is 3. CGPA is out of 10. Suppose someone has got 6. And research done or not, right? So suppose yes. You should see the result. That is prediction of a chance of that person. That is going to be our prediction. with the help of the model which we created. So let's see whether it gives us the result or not. So this particular model is right now currently running on my local machine. Now see, it has given us the chance. The chance of a prediction, the chance of admission of the student is 4%. Actually, it is 40%. I just need to make a change in my code. I just need to multiply the result with 10, right? So that is actually 100. So it is not actually 4%. It is 40%. So chance of admission is 4%, right? This is what our output is. So the point is that now see what we have done is we created the model, we saved the model with .pickle extension, and we created this kind of a web application. So here in Python, I have used one framework for combining all these things, and I have used a framework called as Flask. There are other frameworks also available. You might have heard about something called as Django. There is something called as Falcon. Now, right now, there is something called as Fast API, and number of them. If you know any one of them, learning others is not that much difficult. Right. So that's what I wanted to show you a web application. Now, what I will do is I will show you how to deploy this particular application onto cloud, so that you people also will be able to make use of this particular application on your machine. Right now, you will not be able to make use of my application because why? Because right now it is running on the local machine 127.0.0.1. So what I will do is I will deploy this particular application onto cloud. For that, I will show you each and everything step by step. So the first step is, first of all, I need to go to the path where all my project files are residing. So this is the path where my project files are there. Now, what I will do, I will copy this path. I will copy this complete path. Okay, I will open command prompt. What am I going to do? If you people remember, I told you I am going to deploy this particular application onto. See, you can deploy it onto any of the clouds. I told you there is Amazon Web Services, there is Heroku Cloud, there is Microsoft's Azure Cloud, right? There is Google Cloud Platform or Cloud Foundry, which is called as Pivotal. Out of this, I will be making use of this. It is free for 2 years, and no need to give any credit card details or debit card details. That's why I'm going to make this. Right. So what I will do is, first and the foremost thing is, I will go and let me clear one of written here. So first thing, I will go to this particular where all my project files are residing. So cd command, and I will directly paste the path. What I have done, I have already copied this path. Okay, if you people remember, I already copied this path. That's what I have pasted here, and then press enter. So I should be in a folder. Always remember, you should be in such a folder where your app.py file resides. This app.py file resides. So I am in that folder. After that, next step to deploy your application is, obviously you should have a uh, account on the cloud on which you want to deploy your application. So in my case, I have already created a account for Heroku Cloud. I have AWS account also, Heroku account. Heroku will be easy for you because no need to mention any details, right? So see, this is a cloud which is actually provided by Salesforce. Sorry, and you can make use of that for 2 years for free. I have already deployed some of the applications. The application which you are going to deploy will be able to see here. Okay, this is a cloud platform. So again, it is free. How to create the account for cloud? Just go and type create Heroku account. It will just take 2 minutes. Okay. So I am already in a directory in a folder where my app.py file is set, and I already have Heroku account. Those who are aware about it, that is good. Those who are not, I will provide you PDF file for all the steps. And all these steps are given in my notes, whatever I'll be sharing, right? Those who are interested, definitely you can go and you can try it out. Okay. So next thing is, the first step to deploy your application onto Heroku Cloud is log into your Heroku account. So the command to log into your Heroku account is Heroku login. See, there are only 6 commands, not difficult. Just type Heroku login and press enter. What it will do? It will take me to the browser, right? And it will show me login button. Again, once again, press enter or any other button. Now it will take me to the browser like this, and it will ask me to click on login button like this. Right? So what I will do, I will click on login. Now once I click on login, I will again go to the terminal or command prompt. Now see, here it is saying that I am logged in as Yogesh PM 5555 at the gmail.com. On Heroku Cloud, I have given this particular account, this particular email ID. Right? So I am logged in. The next step is create the application. So Heroku create. Now here you just need to give name to your application. So what I will do is I will give DPU123. Something like this, I will give the name to my application. If it is available, it will allow us. Otherwise, it will show us a message. So Heroku create DPU. That's what I am trying to give the name to my application. So it is saying that it is done, right? Creating the application with this name is done. That means what? That means that name is available with it. Okay, that means I am good to go. That was the second step. Third step is, see, what are we going to do is, whenever I say that we are going to deploy our model onto cloud. So right now my model is onto my local machine. From this local machine, I am going to put the necessary files onto some repository. And in this case, I am going to make use of a repository called as Git. You can make use of GitHub also. I hope you are aware about GitHub. It's a repository, right? So those files I am going to put on the Git repository. Once that is on Git repository, then we are going to push them to the cloud. That's what we are going to do, right? So the first and the foremost thing I need to do is I need to initialize the Git repository. So to initialize the Git repository, which is again free, you need to type this command git space init, that is git initialize, and then just press enter. So it is saying reinitialize existing Git repository. Okay, to where to our current part. Once that is done, fourth step is, this is optional. If you want to go and if you want to check the status, go and check the Git status. So it is saying there is nothing to commit because we did not ask it to commit anything till now. Okay. So remember this name. Okay, DPU123 is our application name. Now what are we going to do is, after Git status, fifth step will be, from my local machine, I am going to put everything to the Git repository. So for that, the command is like this: git space add space drop. Try to understand. Why git? Because it's a git command. Why add? Because we are trying to add some files from the current directory to the Git repository. What is this single dot? Single dot means current directory. So from the current directory, I want to add all the files to the Git repository. That's what this command is doing. Git space add space drop. Okay, and then just press enter. It will not show you any error, anything. That means you are good to go. Next thing is, whatever we have done, just go and commit. So git space commit space -am, and then in single quote or in double quote, you just need to write down some string, hello, hi, whatever you want, whatever. If you want to write down name here, whatever the string you want to write down, just write down the string. So git space commit space -am space hello. That means this command is just going to commit whatever we had until now. It is just going to commit it, right? And you know what doing the commit, and then just go and press enter. Okay, so nothing to commit. Working tree is clean. Let's see final step. So I told you, from local machine git, from git push it to the cloud. That's what I am going to do. So git space git push Heroku master. So on the master branch, I want to push that particular application which is named as DPU123. If it detects it, then that means that is correct. Everything is correct. Otherwise, we will have to check. Okay. So git space push space Heroku space master, and let me press enter. Let's see if it detects. So see what it is saying. It is saying that no such app as MSW123. MSW123 is the application actually which I have deployed earlier because I just wanted to try out whether it works or not before this session. I just made sure and I deleted that app. Right? That's why. So it is detecting the previous app. but my application name is what? DPU123. So we need to tell Heroku Cloud that MSW123 is not my application which I am trying to deploy. My application name is DPU123. So what I will do is, there is a command to tell it, that is Heroku git colon remote space hyphen a and name of your application. What is the name of your application? DPU123. So Heroku git colon remote space hyphen a DPU123. That means we are telling Heroku Cloud that, okay, MSW123 is not my application which I am trying to deploy right now. My application name is DPU123 which I am trying to deploy. Let me see. So I press enter. It should set the repository to DPU123. Now see, set git remote to this one. Now once again I will go and I will try to run this command. Git push Heroku master. Right? Let me show you. If I go and if I press upward arrow, I will be able to get the commands, previous commands. So git push Heroku master. This is what the command I am trying to run now. Let's see. Okay, so it has started deploying my application of the cloud. Let's see if everything works or not. So see, it has detected the Python app. Let all the things complete. So it all depends how much data you have, what is the size of your model. Depending on that, it is going to take time. So see, whatever the package is, whatever it is needed for this particular application, it is actually downloading everything onto the cloud, right? And once it is on the cloud, you people will also be able to make use of this particular application. Yet we are not done. Let it complete. Try to see. It has actually detected this particular project as a web application. If you can read, top file declares types as a web, right? So that means it has detected our application as a web application. Now we are done, right? Now see this particular thing I was talking. So it has detected our application as a web application. Whatever you have seen till now, it has downloaded everything. From where it came to know that which files to download. So there was one file, that is requirements.txt file, in which we always mention everything whatever is required for that particular project. Now what am I going to do is, if you are able to see this particular link, this is the link with the help of which anyone can access my web application. He may be in other country, right? He may be sitting in California, he may be sitting in Mumbai, Pune, wherever. He is able to access because it is on cloud. What I will do is, I will copy that link. Let me go here. Let me copy this till.com. See, DPU123 herokuapp.com, and just copy that. Open the browser. First of all, let me check whether it works or not. And what I will do, I will send the link in the chat box to all of you. Just see, here we are able to get the same result. Right now, what I will do is, I will paste the link in the chat box. You just confirm. All of you just let me know whether it is working in your case or not. You can find out. I send the link in the chat box. Just let me know whether it is working or not. Are you able to see this kind of a thing or not? And even you can go and you can run. You can put all those good values and just let me know whether it is working or not. So all the participants, please just try to click on that link, whatever I have sent you, and just let me know whether you are able to see this thing or not. I will wait. I hope I am audible to everyone. Can you just confirm, all of you?
Yes, sir, you are audible.
Yeah. So I got reply. Yes. Thank you, Ranjit sir. He's saying it's working. So thank you, Jennifer. Okay. Thank you. I hope some of you have tried it out and they are saying that it's working. So that is called as deployment. That's what I was trying to. This is how, once you develop your machine learning model, you can go and you can deploy it onto any cloud platform you want. Right now, let's come to the code. What is this code all about? So see, I will just double click on this app.py file. What is there is, see, what is the starting point of this code? So the starting point is going to be you if you know that many times, almost all the time, what we people do whenever we want to work on real-time projects, we use object-oriented approach. So in object-oriented approach, what we do is we create objects. So similarly in Python, we have some keywords, right? So you might be knowing about this one, underscore underscore name underscore underscore. So what compiler does is, in the code, compiler is going to look out for this particular name. Wherever it finds out this particular name, that is going to be the starting point, okay, of your application. So in this program, it finds out this particular thing, right? And in that, what am I doing? App.run debug equal to true. So app.run debug equal to true. This is where I can go and I can actually mention the port number and the IP address. So here you can see, if you are able to see this particular line which is commented, this line and this line, they are same, app.run. So here app.run host is equal to and port is equal to. So if you do not give host number and port number, by default the host is 127.0.0.1 and the port number is 5000, right? So if you uncomment this line, this code also I will send you if you are interested, right? So if you uncomment this line and comment this last line, you will see that your model, actually your project is going to run on 8000 model, right? So if someone is saying that link showing something is wrong, so just try it out once again. Try it out once again, or maybe I will have to check in my case if there are more than 5 applications, it might not work. Is it clear? Otherwise, I can send you one more link also, which you can make use of. See, what happens is, I will show you those people who are saying it is showing a message that something is wrong. See, here you will get your model. This is 0 to cloud. Here you will be able to see DPU 1 to 3 now once I refresh, right? It is successfully deployed. It should work in everyone's case. If someone is saying that something is wrong, maybe access rights might not be there. What I can do is I can even go and I can send you one more model, one more link, which I have already deployed. We go here. So whatever you are able to see, this is all provided by Hero. This is for the people who are saying they are able to see something is wrong message. Now please try out this particular link also. Okay, whatever I said. If I go and if I try to click on that, should be able to see the application. So I just clicked on one more link, which you are able to see here. See, it is working. So try it out. Those who said there is no problem. Okay, so let me go to the code fast. So this is going to be a starting point. Now here we are able to see something called as app. So this app has come from where? This app actually has come from this particular line. And what is this? So this is object, we can say. What type of object? It's an object which is created with the help of a method called as Flask. And what is Flask actually? Flask is a framework which is available in Python. So we are creating a web application with the name app or app by using a Flask. So we are initializing a Flask application here with this particular name. And from where am I able to make use of this particular method? Why am I able to make use of Flask method here? Because I already imported the necessary package. See, from Flask, import Flask. So I already imported them. That's why I'm able to make use of this particular thing here. After this, what? After this, you are able to see something called as @app.root. Now see, what happens is our application name is app or app. So our application is actually divided into different routes or routes. So one route is this slash, okay, and another route is this slash predict. Okay, so what happens? This is going to be, this is where you are going to see your first page. Okay, and there is one more thing that is called as slash predict and slash query. Okay, so as name is the app, @app. So wherever it sees @ sign, okay, it means what? It means it is going to access that particular route. So @app.root, that means here it is going to access this particular route. Route means what? It is like as we are going to make use of the links, right? Or the paths, I can say. So it is a route to display the home page. That is nothing but the page where you need to enter all the input values, GRS code, profile score, and all those things. Okay, so it is going to take us to that particular page. Get is a method to get the data from the user, right? To get all the input variables in our case. At the rate cross underscore origin. What is this? So at the rate cross underscore origin, here I am able to make use of that because I have written this one. From class underscore course import course and cross underscore origin. What is this cross underscore origin? It is going to what it is going to do is, for example, I am in some network, okay, and this is where my application is. Now you people are in some another network, but still you people want to make use of my application without any problem, right? So even though you are in another network and still you want to make use of my application, so this at the rate cross underscore origin is going to take care for that. So it is going to take care for the platforms, different platforms I can say. So at the rate cross underscore origin is for that. And here I am defining a function called as homepage, which is returning you a render underscore templates index.html. Now, what is this index.html? If I go in templates folder, here you will be able to see index.html. So it's a .html file, which you can get from any other web page according to the design you want. And here we have designed a very simple page, right? So if I go and if I try to show this particular file, this is just the HTML code. This just for beautification, I can say, a front end, right? But what is important? Logic is important. So whatever you want, GRS score, profile score, SOP, everything is mentioned. So a simple HTML code, I can say. Right? I will again go to app here. So this is the home page definition I have written here. After that, you can see at the rate dot root, at the rate app dot root. Now we are in predict root. So what are we getting? What are we doing here? We are posting the results. And if you want to get something, we can get that. So this is what we are going to do. This method we are going to make use of. And again at the rate cross underscore origin, because we want that particular route to be used by people who may be in the another network. Right. And this is the main thing which is going to start. Define index, request dot method is post method. And see, this is where we are going to take the values from the user. GRS score request.form. What is request.form? That means the request is coming through forms, HTML forms, right? That's why request.form, and it is converted into float line. And same is for profile score, university rating, SOP, LOR, CGPA, and is research done or not. So as it's a categorical data, that's why I am writing down a simple if condition. If is research equal to yes, it is converted to 1. If it is no, otherwise it is converted to 0. That's it. So here we are just trying to take care that our data should be converted into numerical values. Okay? And see, file name is what? This is what? Finalize underscore model underscore finalize underscore model.pickle. That file is already there in this directory. This one. So and this file, how we got it? I already showed it to you in Jupyter, right? So I am just trying to assign it to a file name. What am I doing? Pickle.load open mode open file name. In which mode? Read and manage mode. Exactly the same thing we are doing here, which we have done in Jupyter. And I'm assigning it to loaded underscore model. And what we do after this? Loaded underscore model dot predict. Predict for what? Predict for all these values. Research. And from where we got all these values? From the users, right? From the forms. That's what. And finally, dot predict method is going to do is it is going to do what? The prediction result will be stored in prediction variable, and we are just printing the prediction is whatever is there, whatever the value is there in prediction, that value it is going to print. And as I told you that I am multiplying this particular result with 10. That's why it was 0.4. Actually, it was 40%. So I should go and I should multiply it with 100. Right? What is this? It is returning render underscore template results.html. What is result.html? This is the HTML code, right? So if I go and if I double click on this, you will be able to see your chance for prediction is simple HTML code, right? So review page. I will again go to app. So once you get the result, you can that result will be displayed or rendered onto result.html. And if there is some problem, you will be those people who said that they were getting some problem. So the exception message is E. So something is wrong. So the people who were able to see this kind of a message, there might be a reason. Security reason might be there, or maybe some problem will be there, which is a standard exception. right? And otherwise, finally you will get index.html, right? This is what the code is. If I want to show you what is there in requirements.txt, see, requirements.txt is the standard file where we write down all the packages which we need for our project. So what we need is class package, gunicorn, it's a web server available, uh, and all these packages, numpy, scipy. Okay. Proc file is a procedural file. So procedural file we make use of whenever we want to deploy the model. So gunicorn is a web server actually, and we are telling it that okay, my application is a web application, it is going to make the gunicorn server. If I go and if I try to show train.py, in this we'll be able to find out all these import statements: pandas, scikit-learn, for train to split, linear model, pickle, and R square statistics. That's it. Right? And what is this static folder? In static folder we have CSS. You might be knowing about CSS, cascading style sheet. So again, these are ready-made things which are available, which you can get as a ready-made if you want. Whatever the design you want, according to that you can go and you can get. Okay. So this is what the project is, which I wanted to tell you. I actually wanted to show you one more end-to-end project also. Maybe if we get time tomorrow, I will try to show it to you tomorrow also. Okay? I can see that there are only 10 minutes remaining, so I think I should wrap it up. And maybe we can utilize this 10 minutes. If you people have any question, you can please ask. If anyone is having any doubt, anything, you can ask.
I request participant, if you have any doubt, you can ask.
Yes, anyone any doubt or clear? See, I just tried to keep it to the project level only, or application level. Okay, Flask versus Django. So Mr. Ranjit is asking Flask versus Ranjit Singh. Mr. Ranjit Singh is asking Flask versus Django. So see, the difference actually, as I told you, I will tell you it in simple words. If you ask me as a developer, if you ask me, right, I will see what type of a client is in front of me. If he is ready to pay more money, I will go with Django. Otherwise, I will go with Flask. And one more thing, let me tell you, in terms of speed, or if you specifically want to compare Flask and Django, there are a lot of ready-made things which are available in Django as compared to Flask. And as I already mentioned, Flask is there, Django is there. Similarly, there is something called as Falcon, and one more is there right now, that is called as Fast API. Out of all these, the fastest one is this one, Falcon. So framework is not a problem. You can go with any of the frameworks which you are comfortable with, right? But yes, depending on the features, it may vary. If you are asking me about these two, definitely a lot of ready-made things you will be able to see in Django as compared to Flask. But to start with, if you want to learn frameworks only, I will say that Flask is good to start with. I think it's clear, sir. Am I able to answer your doubt? Yeah. Okay. Any other doubt? Any question? Yeah, thank you, sir.
Sir, Yogesh sir,
Yes, sir.
session is very nice. So, any doubt from the faculty, please share your mail ID so that if any doubt is there,
Yes, sure.
we will resolve afterwards also.
Okay, if anyone is having any doubt, I will just put my email ID here, and I will be happy to help you if needed. Yogesh PM 5555 @gmail.com. This is what my email ID is. And even you can find me out on YouTube also. There are a number of projects which I have actually put on YouTube. Just name of it. You can find me out on YouTube also. Yeah, anyone is having any doubt, can just send me email.
It was a very nice session, sir. Now Lakshman sir will speak about the session and he will propose the vote of thanks. You want to continue, sir, or from your side finished?
Yes, madam.
Finished.
And
Okay,
yeah.
Lakshman sir, please.
On behalf of
Hello.
yes, ma'am.
Ha, sir.
Am I audible? Hello. Am I audible?
Yes, sir. You are audible.
I want to represent the vote of thanks. Our today's resource person Yogesh sir. I'm really very thankful to Yogesh sir because you are just providing in-depth knowledge about the machine learning and practice approach. So it was very nice and informative session. I hope all the participants are also enjoyed this session, and we also hope same thing in next session also practical approach. Thank you very much for as a participant for your joining the session. Thank you, sir.
Thank you
So
so much.
okay, sir.
Thank you, sir. Yogesh sir.
Yeah, thank you, madam.
Okay, sir. Again, we are meeting for the sessions.
Yeah, yes,
Yes,
madam.
yes,
So,
yes, sir. Thank you, sir.
thank you. Bye, all of you. Thank you. Thank you
Okay,
all
sir.
so much.
Bye.